Today we are joined by Jack Silver, Teledyne ISCO's application chemist. With that, I would like to turn it over to Jack.
Thank you for joining us today. We will talk about some very large columns and how to run them. There is nothing special about these columns other than their size, so method development and scale-up methods apply to the smaller columns too. Our agenda opens with a description of the large 7 kilogram silica and 8.6 kilogram bonded phase columns. We will then describe how to develop methods and scale up from small columns to large ones. We will talk about how to estimate sample loading, and finally we will discuss the care of these columns and how to connect them to other flash systems. So what are these 7 kilograms and 8.6 kilogram columns? These columns are available in silica, reverse phase, and amine. I'll refer to reverse phase and amine as bonded phases to differentiate from bare silica. The silica columns can, with sufficient resolution between peaks, run a kilogram of sample at once, while the bonded phase columns can generally purify up to 2%, about 170 grams in a run. Customers have used the silica columns over a period of about 48 hours. The bonded phase columns can be washed, but customers generally limit the number of uses based on the possibility of carryover from previous runs. Teledyne ISCO sells 3 types of reverse phase. The C18 AQ is better for water-soluble compounds, while the C18 is a good general-purpose reverse phase column. Both columns work well with compounds that elute mostly in organic solvent. The C18 AQ resists phase collapse and can be run at very low organic solvent compositions, less than 5%, and it shows better retention for very polar compounds. If the desired compound elutes in less than 50% organic solvent, I tend to use the AQ type column. The RediSep C8 is useful for peptides because it has 200 angstrom pores. This actually gives more accessible surface area to peptides, which are large columns, than the 100 angstrom pores on the other C8 reverse phase media. The peptides cannot fit into small pores. The amine column is useful for basic compounds or compounds that decompose on bare silica. There is no need for a solvent modifier when running amine columns. In the previous slide, the column appeared very large. Why would you want to use such a column, and when is it useful? This is a partial list of applications using these columns. We'll have examples of peptides and small molecules later. Many compounds are highly active for biology, such that a single purification on one of these columns is sufficient to supply many customers or users. For example, nanograms of fluorescent dyes are needed for a single cell experiment. These columns can purify 200 or more grams at once, enough for millions of experiments. For natural products, such a large column can be used to purify kilograms of crude extract at one time. Users familiar with the torrent may ask about the advantages of the 7 kilogram silica column. A 3,000 gram column already runs at 900 ml a minute. A 7,000 gram column has a bit more than twice the silica and twice the column volume and runs at 1,000 ml per minute. So what are the advantages? The larger column volume and increased flow rate allows 15% increased throughput compared to the 3,000 gram column. Furthermore, the system is set up once for a given sample. In GMP situations, there is reduced documentation needed because the 3 kilogram column would need 2 runs with twice the documentation as the 7 kilogram column. In any production or lab situation, reducing the number of setups reduces the chance for mistakes. The torrent system is ideally suited for running these large columns. There is a choice between solid and liquid loading, and users have a choice between a fraction collector or a fractionation valve that can collect fractions of any size. There is also an optional solvent switching valve that can also be used to load a large volume of sample through the main pumps. Here is a list of recent references where the torrent was used. Many of them used the torrent to purify samples for clinical trials. Method development and scale-up are intertwined, so I shall cover them both together. Teledyne ISCO has matching analytical and HPLC flash columns which allow easy method development and scale-up with no worries about selectivity changes. This slide shows an overview of the workflow for method development and scale-up. You can create and optimize the method on small columns and scale to larger ones. And then once you have the system, the method optimized, you can just run samples as much as you need to. Here's an example of selectivity changes on C18 with different columns. As shown earlier, the C18 AQ columns show increased retention for polar compounds, while the nonpolar compounds in this example have decreased retention, demonstrating selectivity changes between the RediSep C18 and C18 AQ. The resolve column has very different retention, and method development using that column will fail when the method is applied to Teledyne ISCO columns because the peaks will elute at the wrong time. The 8.6 and 7 kilogram columns are just large flash columns, and the best way to develop and transfer methods is by using column volumes. A column volume is the volume in the column for solvent. It is just like the void volume in HPLC. It is easy to scale from the small columns at the bottom of the image to the large column. TLC plates work very well for normal phase method development. If the TLC plate is run properly, the retention time in column volumes is 1 over the RF. The biggest error I see from customers is that users don't saturate the TLC chamber properly. This is a small molecule purification. This example uses the focused gradient generator in PeakTrack to generate a focused gradient method that can be scaled up to the torrent and the large columns. The first one used a 4-gram RediSep gold silica column on a next-gen system. The desired compound is the second eluting peak. A calculated gradient was run on a 40-gram RediSep gold silica column in the center run using the flash focus gradient generator in PeakTrack. A small amount of sample was run on the column and the calculated gradient was tested. The bottom run used the same gradient method in column volumes on a RediSep gold 7,000 gram column. The sample was loaded neat because it was liquid. 210 grams of sample was run. This was a 3% load for this column. Looking at the resolution, I probably could have run a 5% loading, that is 350 grams, but 210 grams was all of the sample that I had. The focused gradient run was in terms of column volumes, and I used the same method in column volumes on the torrent. The start and end composition was originally the same for the 40 and 7,000 gram columns, and the gradient length was originally the same. However, I ended the 7 kilogram column after the peak eluted, so the run is truncated. Ending the run saved time and solvent, and I knew there was nothing else coming off the column because of the run on the 40 gram example. The next gen can also calculate focused gradients from analytical HPLC. This feature is built into PeakTrack on the next gen. The mixture is run on an analytical HPLC using a calibrated scouting run. In this example, the second peak was chosen. The column used on the analytical HPLC was a RediSep Prep C18 UHPLC column, which matches the flash column C18. The next-gen system is used to calculate a focus gradient. The desired compound eluted near the middle of the gradient on the RediSep Gold C18 column. Just as in the previous example, the method was transferred to the Torrent 8.6 kilogram C18 column. The same column method was used on the next-gen flash system. The starting and ending solvent composition was used again, and once again, the focus gradient length was in column volumes. 130 grams of sample were loaded, which was 1.5% column loading. After elution of the second peak, the run was terminated. The inset picture shows the difference in scale. The 8.6 kilogram method was calculated from that tiny UHPLC column, smaller than the leg used to support the 8.6 kilogram column, and you can barely see the analytical column in this picture. It is easy to scale up from an analytical HPLC to a flash system. See application note 118 on the Teledyne ISCO website for more detail. Develop the method on the analytical HPLC. Convert the gradient in time to column volumes using the equation in number 5 in the slide here. We listed the column volumes for Teledyne ISCO analytical columns in application note 118, but they are also displayed on this slide. Here's an example of a scale-up from a 15.5 gram flash column. I ran all of the peptide I had left, that was more than 5 grams, on the 8.6 kilogram C18 column. It eluted very cleanly. The large peak eluting just after one column volume is some DMSO used to initially dissolve the sample. The peptide is water soluble, so water was added to dilute the DMSO so the peptide peak would have very good peak shape and elute very well. Here's an example of a natural product. Tetrahydrocannabinol, THC, was removed from cannabis extract. The loading was 10% and step gradients were used to reduce the runtime. After the time window, the solvent composition was changed to a lower organic concentration, which equilibrated the column for the next run. When this run was finished, the next run was started automatically and the sample was loaded. This unit used the solvent switcher and sample loader, which allowed multiple unattended injections. Sample loading is dependent on the resolution between peaks. The focused gradient used in previous slide gives nearly the same resolution as isocratic runs. The loading is usually lower when using bonded phases because the sample interacts with the ligand. Compounds can interact with the entire surface of silica column, which is much greater surface area, so the loading is higher on silica compared to bonded phases. The maximum load is when the peak containing the compound you want barely touches the impurity peak. We really don't care about peak shape. In this slide, the top run is optimized because the compound we want is barely touching the impurity peak. However, the second run can be optimized further as there is a lot of space between the second eluting compound and the impurity. The first thing to do is load more sample. This run used 3% loading, that is 210 grams of sample over 7,000 grams of silica. A 5% loading would have been more appropriate. Gradients tend to reduce resolution, and increasing the gradient slope will cause peaks to elute earlier and reduce the resolution between peaks. Because the peaks elute earlier, the run can be finished faster, saving time and solvent. An extreme example of changing the gradient slope is a step gradient. In this example, the first eluting peak comes out at the same time as the original run, while the increased strong solvent composition in the step decreases the retention for the second peak. Solid load cartridges give the best resolution for small molecules, but are limited in the amount of sample they can load. The solvent switcher allows sample loading as well as solvent switching. The purification pump also works well for loading samples. In this image, the pump is being used to load the sample purified earlier onto a C18 AQ column to remove the buffer. The peptide is focused at the head of the column, which will be washed with water and eluted in methanol. When doing liquid load, it is best to use the weakest solvent possible to try and focus the sample at the head of the column and improve resolution and loading. The torrent comes with the parts needed to connect a peristaltic pump such as the purification for liquid loading. For GMP applications, you can discard the tubing to avoid cross-contamination between runs. Make sure the tubing is compatible with the solvent used to load the sample. If you can load the sample neat, confirm the tubing compatibility with your compound. Now we will talk about how to take care of your column and how to connect it to other flash systems. The columns are shipped dry and so need to be conditioned before use. The columns come with instructions to make them ready for use. Filter the sample to avoid particles that clog the column, and at the end of the run, wash out any buffers or solvent modifiers after the run is complete. Buffers and solvent modifiers tend to dissociate the ligand from bonded phases and so reduce the column lifespan. These columns can be used with other systems than those produced by Teledyne ISCO. The columns use a 1/4-inch wedge lock fitting. Note that adapting to a smaller tubing diameter may cause high back pressure, which will reduce the flow rate that you can run these columns at. Systems that run slower than 800 mils a minute will take longer to run than the torrent. If you have an existing method, you can scale it up to these columns and column volumes as shown earlier. If you need to work in minutes, determine the ratio of column volumes and multiply that ratio by the number of minutes, assuming the same flow rate is used in the original method for each gradient segment. Thank you for your time and interest. Do you have any questions?
Well, thank you, Jack, for sharing your expertise. And if you do have any questions, please enter them through the Q&A function, and Jack would be happy to answer. I also would like to bring to your attention, we have provided QR codes on the screen. Please follow us. This will help you to follow us on social media and to find our YouTube page. This will help you keep up to date with what Teledyne ISCO has been doing. So with that, Jack, I'll turn it over to you. Jack, we are not hearing you. Can you check if you're unmuted?
Yeah, I'm unmuted now. Apparently I have to press 2 buttons on this thing in order to do that. Actually, 3 buttons.
Oh, goodness. Okay, well, now you're ready to go.
Yes, thank you. So the first question is, what are some of the differences in silica that cause retention differences? One of them is pH. The silica can be anywhere from acidic to neutral in terms of pH, and molecules that have polar groups may retain differently based on pH. Another difference is the moisture content of the silica, and having some moisture on the column tends to deactivate the silica and cause earlier retention. And one more item could be the pore size. If the silica has larger pores, it has lower surface area, which causes reduced retention. The next question I have is, why does pore size matter? It's a follow-up, I guess, to the first one. It changes the surface area, as I've just mentioned, so that compounds tend to retain a little faster, tend to retain a little less and elute a little faster. However, there's one exception. Very large peptides tend to elute slower on C18 with a larger pore size. This is because they are so large that the peptide molecules cannot get inside smaller pores. And so that surface area is not accessible to the peptide. So having larger pore sizes actually increases what I term the effective surface area that can be accessed by the peptides. And so they start to retain a little bit better. A third question is, how do I get the focus gradient generator that you mentioned? If you have a CombiFlash Next Gen system, the software will be available real soon now, and you can load it for free onto your Next Gen, whether it's a 100 or 300 or 300 plus. Also, if you have an AccuPep HP 125 or HP 150, the focus gradient generator is built into it, and you can use the focus gradient generator in that instrument as well. Another question is, what factors affect loading? Loading is affected by the peak shape, first of all. If the peak has any fronting or tailing, it takes up more space, so to speak, on the column than a symmetrical peak. And so that tends to reduce resolution. Another thing that affects the resolution is the molecular charge on the peak. So if you have a molecule that has a positive or negative charge, such molecules tend to repel one another, and so because of the electrostatic charge, and so the loading on, say, the C18 is reduced as compared to the neutral molecule. Things that affect both the fronting and tailing and the charge on a molecule is the pH of your mobile phase. And so adding buffers tends to make the molecule in either a charged or an uncharged state, and that reduces fronting and tailing, although you might wind up putting a molecular charge on it. I'd rather have a charged molecule with good peak shape than a mixture of charged and uncharged molecule with poor peak shape. One more question is, what are the column volumes for the columns? The silica columns have a column volume of about 10 liters, that's 10,000 milliliters. Well, the C18 columns have a column volume of about 7,500 milliliters. Will the focus gradient generator be available for the torrent system? The answer to that is I don't know. We are introducing it. Actually, it's complete and it will be released very soon now for the next gen system. And so it's useful to scale up from the smallest system anyway. I don't know if we will have it available for the Torrent system very soon.